Hi everyone, welcome to the first lesson for our new topic 4.4, Newton's laws of motion. Alright, so for today's lesson and Friday's session is going to be like an introduction video. So that's why if let's say you have a basic in physics, right, I believe that these two lessons might will be quite easy for you. Alright, so yeah, we are going to apply Newton's laws of motion to some of the linear motion which the particles are all in constant mass and the motion are actually caused by a constant force. All right, so before I move into the content for today, then we'll be going to do a very quick one. So for you to have an idea for how the three topics that we learned so far relate to each other. All right. So there are two chapters that we have learned so far. So the kinematics of motion in straight line and forces and equilibrium. And we are moving into the third one, Newton's law of motion today. Okay. So the numbering in front here is basically our own progress. So we are following the sequence of 1, 2, and we are moving into the third one. So the one in the bracket is the sequence that based on your syllabus. Okay. So it's just add as your reference here. Okay. So when we when we talk about topic one, right, I always tell the guys that we are only focused in the motion of the particle. So which means we only interested to know that how far the particle move, how fast the particle move, what's the rate of change of the velocity of the particle from the acceleration and so on. Okay. So in this chapter, we are not interested to know that what's the thing that actually caused the motion. So in another words, we actually calculating or we actually find out all the motion without considering what's the thing that caused it, which is the force. Okay, and then under this chapter, we have learned some formula for constant acceleration, which is the SUVAT formula. Okay, then when we move on to the second topic, right, we talk about forces. So when we talk about force, we learn how to resolve our force to two different components, right? So either vertical or horizontal, or if let's say you are solving a question for a plane, then you will be doing either along the plane or perpendicular to the plane. Okay, so that's the idea. Then after that, we're looking at the second part is the state of equilibrium. So which means that all the situation that we are looking at is basically the one that without any net force. So the net force is actually equals to zero because equilibrium meaning that the resultant is zero, right? So that's why the net force is zero. And because of there's no net force, so our acceleration is actually equals to zero. So which means that there's still a possibility for the object to move in under this case, it's just that the acceleration will be zero. For example, like the constant velocity that we discussed. Okay, so under this topic, the motion that we see is only either at rest either limiting equilibrium if let's say we take into the consideration of friction, then after that like the last one that I mentioned just now, constant velocity. So now in topic three, we are going to combine these two and then we move another level up. So which means that what we are looking at is also forces, but now what happened is that we have our net force here already. So which means that the object is not in equilibrium anymore. So that's force that actually cause an motion. So when I say motion, it did not mean that it's like just a motion. It's a motion with acceleration. You get what I mean, right? So the acceleration is no more zero. Okay, and that this is the time that we are going to look at how the force is going to relate to the motion as well. So which means that we are going to look at how force affect the motion, and perhaps in the process we are going to use some of the SUVAT formula that we have learned in chapter 1 as well. Okay, so I hope that you can see the whole idea how this thing works. So generally in terms of like the theory, right, what we will be using in topic 3 is basically what we have learned previously. So for example, we are going to use the SUVAT and also for topic 2. And in the topic 2, because we already discussed some of the thing, for example, like the Newton's law of motion, the weight, and then either the tension and so on. Those are the things that we'll be using in topic 3. It's just that now in a different form where there is acceleration involved. Okay, So for today's session and for Friday's session is going to be like an introductory video for force and how to use the formula for F equals to ma. So if you have a basic in physics, I guess it will be quite easy for you. So yeah, then after that, we are moving into the part where we combine everything together and we try to look at the harder example. All right, so that's the idea. Okay, so let's start with the lesson. All right, so let's do some general knowledge here. So we know that force causes motion, right? Then how force is created is actually from the interactions between objects. So based on the interaction between objects, we can actually categorize those forces into two different types. So the first one is what we call as the contact force. Then the other one is opposite of this one, which is called as the non-contact force. Okay, so yeah, you can try to understand it from the word itself. So when we try to talk about contact force, which means that the objects interact and their interaction is actually touches each other. Okay, so for non-contact force, mainly it's about attraction or things like they repel each other. So this force can be generated even though the objects are in a certain distance. Okay, so now let's try to think of some of the example of contact force and non-contact force that we encounter in our real life. Okay, so like the first one, I think this one is very straightforward. We have applied force. So this one, yeah, is easy lah. So which means that when you try to push something, pull something, kick something, you are trying to apply force on that object, right? So this is the apply force. Then after that, in the previous chapter, we talk about tension. So if you still remember, we mentioned rods, string. So how you connect two objects together by using a connector and so on. So that's a thing that that's a force that actually generated, because how are you going to bring force to that object is actually by connecting them together, right? So they are touching each other as well. So tension is one of the contact force. Then after that, we also have friction. Yeah, because of you have applied force, then if let's say the objects can get in touch with the surface and you have friction, am I right? And the next one, we have the normal reaction, okay, the normal force. So if let's say you try to put an object on the table, then that's weight, then that's normal reaction, right? Okay. Then the last one, which is a main type of the contact force as well, but we are not looking at it like so much in our syllabus for A-level maths, so which is the spring force. Okay, so I try to use a star here maybe. So this is the one that we don't actually see it often. Okay, so that's the idea. Okay, so now how about non-contact force? So what are the example that you can actually think of? Okay, I think the first one is the one that is very easy, the one that we actually mentioned it before, which is the gravitational force. Okay, so yeah, basically, you yourself and the earth, we did not really say that they touch each other. So it's basically the force that exert from the earth, right? So gravitational force is one of the popular force that when we mention non-contact force. Then what else do we have is things like electric force. For example, attract and repel. So we have also magnetic force. And perhaps one more, we have nuclear force. Okay, so all these force is actually generated without the objects getting touched to each other. Okay, so for non-contact force, basically in our syllabus, we only look at the part for gravitational force. Okay, so yeah, I'm actually writing down. So this one, this one, this one, this one, and also gravitational force are all the popular forces that we will be looking at in A level. Other than that, is not in our syllabus. Okay, all right, so let's start with the next part. All right, so same thing. This part is just a recap on the content that we have learned previously that we are going to use it in this lesson. Okay, so in lesson 3, I'm sorry, this is supposed to be the topic 2, lesson 3. Okay, so we have learned Newton's law of motion, right? And we know that the second law tells us how force relates to the motion of an object. Okay, So they are relating to each other in the form of the force is proportional to the product of the object's mass and also acceleration. So from there, we have a formula that tells us that force is equal to mass multiply acceleration, which is F equal to ma. Okay, so one of the application for force is actually the weight. So that's why we have W equals to mg as well, which our g is equal to 10 meter per second square. Okay, so I hope that by this time you should be quite familiar with this already. If let's say you still have any problem with this, then please go and do some revision on the topic 2 lesson 3. So this is the SUVAT formula. So yeah, if you still remember, so basically there are four different equations that connects four out of five variable that we have in motion. So the initial velocity u, the final velocity v, the acceleration a, the time t, and also the displacement, which is s. So we are going to use all things to solve some of the question here, and basically that's the lesson today. All right, let's look at the example. So before that, just a note here, right? So for all the examples that and the exercise that you are going to do, so all the force involved is just in one dimension. So which means that we are not going to resolve any force in this particular lesson and also the next lesson. So the idea is I want you guys to get familiar with how to relate the equation of F equal to ma and the SUVAT formula first. Then after these two lessons, then we are only going to combine everything together so that you are not having too much of the thing at one time. Okay, so let's try to look at number one here. So a cyclist and his bike have a combined mass of 100 kg. So a cyclist accelerates from rest with acceleration of 0.2. So find the force the cyclist generate. Okay, so I think this is easy. So the question already gives us that they have a mass of 100 kg. Then after that is acceleration is 0.2, right? Then the question wants us to find out the force. Okay, so basically it's just by using F equal to ma. So let's substitute the number. So 100 and then 0.2, and from that then we can get our answer 20 Newton. Okay, so as simple as that. So now B, the second cyclist and his bike have a combined mass of 80 kg. So we can just write down first. So 80 kg. So mass is 80 kg. So the cyclist generate from rest and generating the same force as the first cyclist. So that's why the force involved here is also 20 Newton. And the question wants us to find the acceleration. So which means we need to get A in our question here. Okay. So how are we going to do that? Same thing is just M equal to F equal to MA. Okay. So substituting our value here. So 20 will be equal to the mass is 80 and then A. So from here then we can get A equal to 0.25 meter per second square. Okay, so I think that's pretty straightforward. So now let's try to look at C. The first cyclist is traveling at 20 meters per second when he starts to brake with a force of 500 Newton. Okay, so find the distance covered while coming to rest. Okay, so we know that the cyclist is traveling at 20, so this is like the velocity, right? Or the initial velocity, because when it comes to rest, then it will be final velocity, which is 0. So in this case, when he starts to brake, right, if let's say in A and B, we try to assume that the force that he tried to cycle is actually a positive. So which means now when he starts to brake, the force is actually in a negative direction. So that's why our F here will be negative 500. Okay, so this is important because when we talk about force, right, it's still a vector. It's still a vector rather than a scalar. So you have the magnitude part and you have the direction part. So this is why we have the resultant force, right? And when we try to resolve, we have the left hand side and right hand side, like whether it's going to the left or going to the right. So that's why it's the same thing. So for this one, it's like you are trying to speeding up or you are trying to actually slowing down. So that makes a difference in your force. So by having this, then now we can actually find the acceleration, right? Because we actually has the mass of the first cyclist already, which is 100. So by using the same equation, which is F equal to MA, then we can have negative 500, okay, will be equal to the mass here. Actually, okay, the mass here is 100, all right, and then A. So from here, then we can know that the acceleration is negative 5 meter per second square. Okay, which this is correct because what happened here is you are moving and you want to brake until it come to rest. So your acceleration should be a deceleration, right? So that's why getting a negative number is correct. Okay, so now what do we have? We have the initial velocity, which is 20. And we also know that it comes to rest, so the final velocity is 0 and the acceleration is negative 5. So the question wants us to find out the distance covered. So that's why we are trying to find out the displacement. Okay, so now we need to use the SUVAT formula in this case already. Okay, so for U, V, A, and S, so we are using V square equal to U square plus 2AS. So just substitute the value. So 0 square equal to 20 square plus 2AS. Okay, so from here I can get that 10S is equal to 400. So that's why the S here will be equal to 40 meter. Okay, so I hope that is a very easy example for you to understand how they relate those together. Okay, now let's try to look at example 2. Alright, example 2, a block is being dragged along a horizontal surface by a constant horizontal force of size 45 Newton. So the F involved here is actually equal to 45. So it covers 8 meter in the first 2 seconds and 8.5 meter in the next 1 second. And the question wants us to find the mass, which is the M. So we know that by looking at this, we have F and N. So if let's say we need to find the mass, right, which means that we need to get our acceleration first. So how can we get this is from the two information that's given here. So the block covers 8 meter in the first 2 seconds. So which means that we know that when t equals to 2, the s is actually equals to 8, right? Then after that, it covers another 8.5 meter in the next 1 second. Okay, so you have two choices here. The first one is either you want to build another one which t equals to 1 and s equal to 8.5. So if let's say you try to do like that, which means that you are comparing the initial velocity of this, the final velocity of this one will be equal to the initial velocity of the other one. So is that any easier way to do it? Okay, because we can see that the block is actually dragged along a horizontal surface, right? So which means that we can assume that there's no change of direction happens here. So that's why, which means that it will be easy for us to add them up together and to state that when t equals to 3, the total displacement travel is actually equal to 16.5. So why is it easier to do so? Because if by having these two information, then we have our initial velocity is the same. Am I right? So that's why, and we want to find the acceleration. So we are sharing the same variable for these two, and we can use the exact equation as well. So for us to connect T, S, U, and also A, then we can try to use the equation of S equal to UT plus 1 over 2AT square. Okay, so let me just try to write down for both and we'll try to form the two equation. Okay, so the first one we have our S is 8 and then U is an unknown for us, right? Then T is 2 plus 1 over 2. So A is the variable, then T is 2 and then square. So from here we can get 8 will be equal to 2U plus 4, so 2A. So that's my first equation. Okay, so move on to the second one. So I have 16.5. So since they are both in the same scenario, right? So that's why the U here is the same with the U here. And then I have 3 plus 1 over 2 and the A here and T is 3. So after I solve this, then I'll be able to get 16.5 equal to 3U and then 9, so 4.5A. Okay, I think we can all divide by 1.5. Yeah, 1.5, 11. So 11 will be equal to 2U plus 3A. Okay, So you can see that it's just nice that we have 2u and 2u, so we can straight away solve our a here. So by using the second equation to minus the first equation, then we can get 3a minus 2a, right? Then it will be equal to 11 minus 8. So we can get a will be equal to 3 meter per second square. Okay, so by having this, we can substitute into F equal to ma now. So the force that exert here is 45. And then the mass is what we want to find, and then 3. I'm sorry, maybe you need to write a bit here. Okay, so from here, then we can get our mass will be equal to 15 kg. Okay, I guess that's easier. It's just simultaneous equation. You need to form two equations. Then after that, you find your A. Then you use your A to help you to find the mass. Okay, so now let's try to look at number 3 and 4, which you have more than one force, which you can see there's air resistance that exists. All right, number 3, an aeroplane of mass of 8 tons is flying horizontally through the air at 240 meters per second. So let's try to write down the information because I guess it's quite a lot in this question. So the mass is 8 tons, so that's why it's 8,000 kg. Okay, then it's flying horizontally through the air at 240 meters per second. So that's why we assume that is the initial velocity is going to be 240. So the air resistance, that is air resistance of 20k. So let's try to write this is the resistance force. So we have 20,000. Okay, the pilot reduces the driving force from the engine to slow down to 160 meters per second over 40 seconds. So the final velocity is to slow down until 160. So the time is 40 seconds. Okay, so find the magnitude of the reduced driving force. So meaning that what's the driving force for now? Okay, so that's the idea. So which means that for us to find it, so same thing, we need to know that if F equal to ma, right? Okay, so we need to find the force, so which means we need to know the mass and also the acceleration first. So can we actually find the acceleration? So that's only three variable that relating to motion. So we have u, v, and t. So that's why we can find our acceleration by using v minus u over t. Okay, so the v here is 160 minus 240 divide by the time is 40. So from here, then we can get negative 2 meter per second square. Okay, so this is the acceleration, which is a deceleration lah. That's correct because you are trying to slow down the plane, right? Okay, so after we did this, then what we can try to do, so F equal to ma. So what is our force that actually apply on this aeroplane? So we have this driving force, right? So we can try to write the driving force. Okay, then what happened is we have air resistance. So that's why we need to use our driving force to minus the air resistance. Then only you can produce the net force for the plane to actually move. Am I right? So that's why we want to find the D, which is a driving force here. So D minus 20,000 will be equal to 8,000 multiply negative 2. So from there, we can get our driving force is actually 4,000 Newton. Okay, so which means that in this case, I'll need to have the driving force of 4,000 Newton to balance out with the air resistance, which is 20,000 Newton, so that the aeroplane can have an acceleration of negative 2. Okay, so imagine if let's say I do not have this driving force, right, then the motion of the aeroplane will be only depends on the air resistance. Then you will have a higher acceleration, which maybe the plane cannot afford. Okay, so that's the idea that why do we use the driving force to minus the air resistance, because the air resistance is the one that actually avoid the motion of the driving force, right? All right, so that's why minus. Okay, it's the same thing also if let's say we want to we try to understand it from the diagram. So yeah, I mean this is like a plan, right? Then after that, what happened here is the driving force actually moving forward. Okay, so air resistance is the one that hold the aeroplane back, right? So that's why 20,000. So they are actually in a different direction. So that's why it should be the driving force minus this one that caused the motion of the aeroplane. Okay, so that's it. So let's move on to the last one. Okay, number 4, a car of mass 600 kg has a driving force of 500 Newton and air resistance of 200 Newton. So find how long it takes to accelerate from 10 meter per second to 22 meter per second. Okay, so let's try to write down the information. So we have the M is equal to 600. Okay, then the driving force given F here is 500. Then we have the resistance, which is 200. Okay, so find how long it takes to accelerate. So which means we need to get the acceleration first, then only we can find out, right? So our net force is actually equal to ma. So what is the net force in this question? Okay, here maybe I need to write this is df, the driving force. Okay, so what's the net force here? So we have the driving force, which is moving forward, right? Then the air resistance actually holds the car back. So that's why the net force in this question is going to be the driving force minus the air resistance. Okay, then it will be equal to 600 multiplied by A. By having this, then I can find out that my A is actually equal to 300 over 600, which is 0.5 meter per second square. Okay, so by having the acceleration now, since that we already have our U is 10, then our final velocity is 22, so that we can get our T here just by using a simple formula, which is either you want to use the V equals to U plus AT, or it's the same thing if you try to use A equals to V minus U over T lah. Yeah, basically they are just the same. So 0.5 equal to 22 minus 10 over T. So from here I can get 0.5 T12. So that's why I can get T equals to 24 seconds. Okay, so I guess it's pretty straightforward. So part B now, the car stops providing a driving force and the brakes are applied. Okay, so the car decelerates from 22 meter per second to rest in 220 meter. Then the question wants us to find the force of the brake. Okay, so in this case, right, we can imagine that just now we say that the net force is equal to ma, right? So what do you think is the force that exert in this place? So the question says that the car stops providing a driving force, so which means you do not have the 500 Newton anymore, but the air resistance remains there, right? Then you have the car brake. Okay, so now my question is, this is the driving force, then this is the brake, right? So sorry, this is the air resistance. So do you think the brake is going to be the same direction with the driving force, or is in the opposite direction? So you can imagine that the brake is to stop the driving force, right? So that's why it will be in the opposite direction. So that's why both of your air resistance and your brake are both negative. So what you are doing here is to find the brake. Let's try to do B. So that's why I have negative my brake minus the air resistance will be equal to ma. Okay, so in this case, then we might need to find out what is our acceleration, then only we can proceed. So it decelerates from 22 meter per second, so which means our initial velocity is actually equal to 22. So to be at rest, so that's why its final velocity is 0. The total displacement is 220, and we can find A. Okay, so by using the SUVAT formula of V square equal to U square plus 2AS. Alright, so let's substitute. So 0 will be equal to 22 square plus 2A, and the S is 220. So from here that I can get 440A is equal to negative 484. So we can get A will be equal to negative 1.1 meter per second square. So which is correct because now you are braking the car. Okay, so now we can try to substitute in this formula already. So we want to find the brake force, right? So B minus the resistance just now is 200, and it will be equal to the mass is 600, and the acceleration is negative 1.1. So by having this, then we can try to solve our B. So negative B is equal to, so 1.1, so it will be negative 66. Right, am I right? So 1.1 multiply 600. So I'm sorry, 660. Oh yeah, 1.1. Okay, then I bring this over. So plus 200. So from here, then I can get B will be equal to 460 Newton. So which is correct now. So you should get a positive number, right? So because, okay, so when you try to calculate the resultant, you need to take into the consideration whether you need to minus it or you plus it. But when we try to talk about force, right, we wouldn't say like negative force. You get what I mean? We try to put negative here is to indicate that it's opposite with the force that we exert as the driving force. So that's why is, I mean, okay, now this is the driving, right? So what happened here is you have resistance here, then we try to break here. So when we try to do our F equal to ma, so our a here will be negative as well, like right? It's because of now your acceleration is towards this direction as well. So that's why to keep this idea to keep the a as our negative, so to not to change this to positive, so which means we are still considering going to the left is our negative direction. So that's why when you try to do this, then it will be negative b negative r. So that's why your answer, you should be getting a positive answer lah, because you're already negative in your equation, and that's correct. Okay, so that's the idea. So I hope that you can spend some time to do the exercise, and I guess the idea is not that difficult. Is the only thing is you need to be careful of your positive sign or negative sign, whether you need to plus or you need to minus. So you can always do it by drawing a diagram. So it may an easier one, the arrow, so that you can see whether it's the same direction that you need to plus or in the opposite direction that you need to minus. Okay, so basically that's the part. All right, so yeah, that's end for this session. Thank you.